Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE Computer Science and Data Science. So in this video we are going to discuss some of the questions based on homogeneous system of linear equation. And in last video we have discussed different types of solution homogeneous system of linear equation has. So we are going to continue this. If anyone hasn't watched the previous video, so just go through the previous video in which we have discussed different types of solution of homogeneous system of linear equation and we tried to find out the solution. Now in this video we are going to discuss some of the GATE questions based on this homogeneous system. So first of all, let me just give you a quick recap what we have discussed in homogeneous system of linear equation or what would kind of solution looks like. So we have discussed that Ax equals to b, the system of linear equation. If right hand side would become completely 0, this right side vector would be 0, then Ax equals to 0 is called as homogeneous system of linear equation. And one thing we got that it would always have a solution. Right, it would always have a solution because I'll substitute x with 0, a into 0 would be 0. Right, so 0 solution always be there. So then we have discussed about the solution. So we have said that it would only have two types of solution, unique solution and infinitely many solution. It does not have no solution. Why? Because it would always have a solution, that is a 0 solution. Right, so I have discussed unique solution and infinitely many solution. Infinitely many solution. There are only two types of solution. So because we have taken the system Ax equals to 0 and we have said that 0 solution would always be the solution. And if I'm talking about a unique solution, so that means unique solution would be 0 solution. Either we say that this is 0 solution or we'll say that it is trivial solution. 0 solution or trivial solution. Right, 0 solution or trivial solution. And for infinitely many solution we'll say that non-zero or non-trivial solution. Non-trivial solution. Non-trivial solution. And then we have discussed that when this system Ax equals to 0 has unique solution. So what we have discussed, when rank of A would less than rank of A is equals to number of variables, then I'll say that A has unique solution or 0 solution or trivial solution. So let's suppose one thing we all know that if A is a m cross n matrix, how many variables A can have? N, because X should be a vector of order n cross 1. And you would get the right side to 0 here, and this 0 vector would be of order m cross 1, right? So what I'm saying, I'm adding one point here. So let's suppose A is a n cross n matrix. If A is a n cross n matrix, that means if it is a square matrix, Ax equals to 0 can have any order, but I'm just writing a specification. In particular, if A is a square matrix of order, right, n cross n, then I can say that this system has unique solution. Ax equals to 0 has unique solution if rank of A is equals to n. That means because number of variables would be n, A is an n cross n matrix, number of columns in A has, that can be number of rows. Rank of A is n, and if rank of A is n, can I say that determinant of A is non-zero by the definition of minor? That means I can say that A inverse exists. And one more thing I can add, that A inverse exists, and I can add one more thing, that is A inverse exists and A is non-singular matrix. Right, A is a non-singular matrix. Similarly here on infinitely many solution, I'll add rank of A is less than number of variables, then I'll get infinitely many solution. Rank of A is less than number of variables. One more thing I have, there is another concept of free variable. Free variable is nothing but with the help of which I am going to find out infinitely many solution. Free variable would become number of variable minus rank of A. That would be my free variable, and these free variable gives me my number of independent solutions. number of independent solution, right? We already have discussed it has infinitely many solution, but in any case if I talk about independent solution, that would be number of free variables, right? And later on I can add that, which I have added here, that let's suppose A is of order n cross n matrix, A is of order n cross n matrix, then system has a unique solution, infinitely many solution, Ax equals to 0 has infinitely many solution if rank of A is less than n. That means determinant of A should be 0 by the definition of minor. That means A inverse does not exist, or I can say that this matrix is non-singular. This matrix is singular matrix. Singular matrix which has determinant 0. Non-singular matrix which does not have determinant 0. Right? So this is a chart you have to remember to work on the solution of homogeneous system of linear equation. So if this concept is clear, you guys can move to solving question. So this is a question here. A system of equation represented by Ax equals to 0. So it is homogeneous system where X is a column vector of unknown and A is a square matrix containing coefficient has a non-trivial solution. Non-trivial solution when A is non-singular, singular, symmetric, Hermitian. Non-trivial solution means we'll have, like you can see that non-trivial solution kahan pe the? Non-zero solution. That is in case of infinitely many solution. So we'll have infinitely many solution. Infinitely many solution. And if I have infinitely many solution, they are asking for non-singular, singular. So they have said that it is a square matrix. If it is a square matrix, I can talk about these things, right? Singular, non-singular, symmetric, all these comes under our square matrix, right? Now, non-singular, that means determinant is 0 or non-zero, singular. So it would be a singular matrix. Why it would be a singular matrix? Because we have said that determinant of A is 0 in case of infinitely many solution. So this is one of the question. Right, now let's see another question. Next question we have here is, if the following system has non-trivial solution, they are saying that it has non-zero solution and we have to find out which of the following condition is true. ठीक है ना, ये non-trivial बोल रहा था, ये भी non-trivial बोल रहा है, ठीक है. So if they are saying that it has non-trivial solution, so that means this system has infinitely many solution, and when the system has infinitely many solution, when rank of A is less than 3, so I can say that determinant A is 0, because either if I'm going to row reduce, I'll get my answer, right? But can I do that with the help of this determinant, right? So I'm going to do that with the help of this determinant. So I'll write down P, Q, R, Q, R, P, and R, P, Q. I'm going to equate it with 0 because my system has non-trivial solution, infinitely many solutions, so determinant of A would be 0 here. Right, so I'll solve this. So how do I solve? I'll apply, I have to apply the operations, right? Column operations or row operation with which I'll be able to find out the determinant. So can I do that? R1 tends to R1 plus R2 plus R3. Or क्योंकि when we are working on determinant, I can either apply column operation or row operation. I can apply anything. I'll show you why I have done that. So it would become P plus Q plus R. The second element would also be P plus Q plus R, and this is also P plus Q plus R, and everything else remains same, Q, R, R, P, P, Q. You would say that, ma'am, why you are applying column operations or row operation? You can solve this determinant directly. We know how to expand 3 cross 3 determinant, right? That is a question. But guys, you can solve it, but they are asking for something simplified, right? If you would expand this, you would get the terms P, Q, R in multiplication and all those things, and that would get really difficult to solve. Difficult to find out the factors, right? You can just try by yourself. So what I can do, can I take P plus Q plus R common from the column 1? I'll take common because I can take column from any row or any column from the determinant Q, R, R, P and P, Q. P, Q is equals to 0. Now I'll see that P plus Q plus R. देखो, P plus Q plus R is only correct in one option, option C. So you can, like, till this point you get the answer that option C is correct, right? You get the answer option C is correct. But here there is no need to solve it further, क्योंकि एक ही ऑप्शन में P plus Q plus R है. बट अगर यहाँ पे भी P plus Q plus R दे रखा होता तो तुम्हें ये वाली कंडीशन भी चेक करनी पड़ती ना. You have to check these second conditions as well. So how you are going to check these second conditions? You have to solve it. Right now you do not have to solve it for this question, but I am just telling you that how to expand it to solve this question completely and get this vector, the second one as well. So let's solve it. What would I do? I am applying the operation here. R2 tends to R2 minus R1 and R3 tends to R3 minus R1 to get it in simpler format. So P plus Q plus R into 1 QR, this would be 0, R minus Q, and this would be P minus R, and this would be 0, and P minus Q, and Q minus R. I got this is equals to 0. Now I can expand it because it has two zeros. I need to only expand it with the help of 1. So I'll get P plus Q plus R, and I'll get 1 into Q minus R square, एक नेगेटिव साइन कॉमन ले लो, माइनस P minus Q and into P minus R. You would get this value equals to 0. Right? You would get this value. And if you are going to expand this, what would it become? Let's expand this. Minus Q square plus, you can just expand this, minus Q square minus R square plus 2QR. इसको भी expand करते हैं. Minus P square and plus PR plus QP and plus minus QR equals to 0. So now one thing you can check here, what you are getting the second term. Second term you are getting, if you would, guys, I am writing it down here because I do not have a space. ठीक है, तो मैं यहीं पे लिख रही हूँ, मैंने येलो पेन से लिखा है वो, that is for the second part. P plus Q plus R, and you got that as minus P square minus Q square and minus R square plus PQ plus Q plus PQ प्लस QR प्लस RP. इस तरीके से तुम एक्सपैंड कर सकते हो. ठीक है, यहाँ पे थोड़ा कॉम्प्लिकेटेड आ रहा है. सब कुछ ठीक किया है ना हमने. RP, PQ, R माइनस Q, P माइनस R एंड P माइनस Q एंड Q माइनस R. ठीक है, थोड़ा कॉम्प्लिकेटेड आ रहा है, बट यू कैन जस्ट चेक कि अगर कोई और फैक्टर्स ले सकते हो तो. Right, otherwise this would be 0 if P is equals to Q is equals to R. That's why they have given only one option in which P plus Q plus R is equals to 0, so that you can just use that and solve it. ठीक है, check the calculation by yourself. Next, this is another question. They have asked this question in 2021. They have said that P is a 4 cross 5 matrix. Okay, we have a P matrix which has order 4 cross 5. Such that every solution of the equation Px equals to 0 is a scalar multiple of 2, 5, 4, 3, 1 transpose. So that means हर एक solution, every solution for this system is a multiple of. So that means x you are getting as 2, 5, 4, 3, 1. That means इसका multiple है. You would take it as a, right, scalar multiple. So A can be any real number. You are getting infinitely many solutions. So they are asking rank of P. Rank of P. So X is equals to this vector. So that means how many number of independent solutions? Number of independent solution in this case, because each solution, every other solution would be a multiple of 2, 5, 4, 3, 1. Right. So that means independent solution is 1. That means what would be number of free variables? Number of free variable is 1. Now you have to move backwards. Previously you have said that rank is this, number of free variable is this, and then number of independent solution. Now I am going back to my rank. Number of free variable, that would be 1. And if number of free variable would be 1, then rank of P is what? What is the formula? Rank of P minus number of, what is my formula for number of free variable? That is number of variable, total number of variable minus rank of A is equals to 1. And total number of variable, because it is a 4 cross 5 matrix, so how many variables it would be? 4 cross 5 matrix, so how many columns we have? 5. Minus rank of A is equals to 1. So rank of A you would get here as 4, right? Rank of P you get here as 4. ठीक है, वो मैंने A लिख दिया, but that is a P matrix. I hope this thing is clear. Now this is another question, and this question they have asked in GATE DA 2024. This is little bit different. You have to understand it very carefully to solve this question. That's why I have taken it, so that you would understand each of the concept, and this would help you to get to know for homogeneous and non-homogeneous system, both the system. ठीक है, क्योंकि यहाँ पे देखो ये non-homogeneous system है, right? So let's try to solve it. So they are saying that M is a 2 cross 3 matrix. M is a, which of the following statement is / are true, they are saying, and I have to check all these 4 options. So they are saying that M is a 2 cross 3 matrix. M is a 2 cross 3 matrix, and they are saying that Mx equals to P has unique solution. And this system would have unique solution. When this system would have unique solution? When rank of M augmented P is equals to rank of M, that would be equals to number of variable, that would be 3. Mx equals to P has a unique solution if it is equals to, right? Now you tell me, M is 2 cross 3 matrix. Is it possible that rank of M can be 2? Would it be possible? क्या ये possible हो सकता है कि rank of M 2 हो जाए? So we would never have a unique solution. Not possible. क्या possible नहीं है? Possible नहीं है हमारे पास rank of M 3 हो जाए. Why? Because M has 2 rows. So rank of M cannot be 3. So this statement is incorrect. This is not correct. Option A is not correct. I hope everyone gets it. Now next is, you have to check next one. This is for A part. I'll check for B part now. For B part, they are saying that M is a 3 cross 3 matrix. M is of order 3 cross 3. P belongs to R cube. R cube means it is a 3 cross 1 vector. Q belongs to R cube, it is a 3 cross 1 vector. M belongs to R 3 cross 3, it is a 3 cross 3 matrix. That's the way of writing. They are saying that Mx equals to P has unique solution. Now it would have unique solution again. Rank of M augmented P is equals to rank of M is equals to 3. Right? And they are saying that Mx equals to Q has infinitely many solution. Infinitely many solution. For Mx equals to Q, what would be? It would be rank of M augmented Q. Rank of M should be less than 3, because infinitely many solution when it has less than number of variable. Can it be possible? Can these two conditions possible at the same time? They are saying that there exists a matrix. For a single matrix M, can it be possible कि rank M 3 भी हो जाए and rank M would be 3, less than 3? This would never be true. So again, option B is incorrect. I am just using the definition of solution, infinitely many solution for non-homogeneous system. Right? This question is based on non-homogeneous. Okay, now option C. Let's see. Let's work on C part. So C part says that M is a 3 cross 2 matrix. Okay, M is a 3 cross 2 matrix. Then they have said that Mx equals to P has unique solution. Mx equals to P has unique solution. What do I mean by that? Rank of M augmented P is equals to rank of M is equals to number of variable, that is 2. Now they are saying that Mx equals to Q has no solution. Has no solution, no solution. So they are saying that rank of M augmented Q is not equals to rank of M. So there is no problem I am getting. I can have a matrix which has a rank 2 with M augmented P. Rank of M augmented Q is not equals to rank of M. That can be true because that is completely dependent on Q. In previous cases I was getting a contradiction that these two things never be possible at the same time, and here rank of M cannot be 3 because M is a 2 cross 3 matrix, but here I am not getting anything. So option C can be true. Option C is true. There exists a matrix M, and you can just take any example, right? You can, it's up to you. D would be there exists a matrix M 3 cross 3 is slash R to true कह रहे हैं, तो it can be MSQ because इस slash R का है. M is a 3 cross 3 matrix. Guys, I am writing down at the bottom here because I do. Can I write down it here? Because I do not have a space. Just a minute. M is a 3 cross 3 matrix. Right? They are saying that Mx equals to P has no solution. Mx equals to P has no solution. That means rank of M is not equals to rank of M augmented P. Then they are saying that Mx equals to Q has infinitely many solution. Mx equals to Q has infinitely many solution. So rank of M augmented Q is equals to rank of M is less than number of variable 3. Again it can be true because it has rank of M augmented P is equals to rank of M. It does not have any combination with this one because here we have rank of M less than 3. It can be true. So C and D can be true, but A and B, because I got a contradiction there, they are not true. Right? So I'll repeat myself once again because this is a little bit different question, and they have asked this question in GATE DA 2024. What is this question? It says that which of the following statement is slash R true? We have said that there exists matrix M such that Mx equals to P has unique solution and Mx equals to Q has infinitely many solution. I have taken the matrix M and I have said that it has unique solution. I remembered the condition which I have known for unique solution. Unique solution says that rank of M augmented P, rank of M equals to number of variables. Number of variables in this matrix, number of columns in a matrix. So we have a 3 variables. So it would never be possible because rank of M cannot be equals to 3. Rank of M because not possible because rank of M would be less than equals to 2 because M is a 2 cross 3 matrix. It has 2 rows. Now another part is M is a 3 cross 3 matrix. They said that M has a Mx equals to P has a unique solution. I just have taken that unique solution. Again I have remembered the definition M augmented P, M both have same rank equals to number of variables 3. And Mx equals to Q has infinitely many solution. What I get? Rank of M augmented P and rank of M less than 3. Now I know that these two conditions cannot be true at the same time. Alright, so that's why it is not correct. Now C says that M is a 3 cross 2 matrix. Mx equals to P has unique solution. So I have written the condition, and Mx equals to Q has no solution. So I got the I do not get any contradiction. And if you are looking for an example, if you feel like okay we are not getting a contradiction, but is it still possible कि we'll always get a matrix? There exists a matrix. So let's take any matrix. I am taking M matrix as 3 cross 2 matrix such that Mx equals to P has unique solution and Mx equals to Q has no solution. 1 0 0 1 1 1. Right? And this is M matrix and P vector I'll take it as 1 1 1. So if you would solve, you would get x is equal x1 1 x2 1. You would get the answer 1 1 2. Sorry, it is 1 1 2 if you would take P. But if you would take Q is equals to, you can check these values by yourself. Mx equals to P would gives you x1 y1. But if you would take in this example, you would take Q is equals to, let's say I am taking 1 1 1 1 0 or 1 1 1 kuch bhi le lo. You can take anything other than 2. You would get 1 1 0. So you can see that x is 1, y is 1, but x plus y is 0. That would never be possible. So Mx equals to Q has no solution. So I have a matrix M, P and Q such that Mx equals to P has a unique solution and Mx equals to Q does not have a solution. Similarly, I'll tell you for D as well. ठीक है, D के लिए भी एक बार डिस्कस कर लेते हैं ऐसी कौन सी मैट्रिक्स एग्जिस्ट करेगी. देयर इज नो नीड टू फाइंड आउट दैट मैट्रिक्स, बट समटाइम्स इफ यू डू नॉट गेट रिजल्ट विद दिस प्रूफ्स, what I have done here, you can use the like example, counter example to not disprove that or prove that, right? Exist बोल रहे हैं, so if we are able to find out one example, our work is done. Now there exists a M 3 cross 3 matrix, P belongs to R cube, Q belongs to R cube, such that Mx equals to P has no solution and Mx equals to Q has infinitely many solution. I'll take this 0 1 0 0 0 0, right? Again, I'm just taking it, this is my M matrix, and P vector I'll take it as 1 1 0. Again, it is not possible, x is 1, y is 1, and x plus like 0x plus 0 y plus 0 z 1 1 1 ले लो इसको. It would never be possible. ठीक है, ये possible ही नहीं हो पाएगा. और Q के लिए ले लो, Q के लिए you can take, you need infinitely many solution, तो Z free variable चाहिए, 1 1 0 ले लो. So you can take any matrix, you can just form all any matrix by yourself, right? So this is a question. Let's try one more question. Let's do one more question. It says that A is an M cross N matrix where M is greater than N. Which of the following statement is true about the system of linear equation Ax equals to 0? So again, this is a question is based on homogeneous system of linear equation Ax equals to 0. So there exists a solution in which at least n variables are non-zero. बोल रहे हैं कि there would exist a solution in which n variables are non-zero, and Ax equals to 0 is my system of linear equation. But they are saying that n variables are non-zero. n variables non-zero होने ही चाहिए. There exists a solution, and there exists a solution m minus n, linearly independent solution to the system. Non-zero solution in which m minus n variables are 0, m minus n linearly independent vectors. Guys, do you remember any condition in which we have discussed that number of elements or number of variables are 0 or non-zero? We haven't discussed that. What we have discussed? We have discussed about free variable. Free variable. That means free variables gives me number of independent solutions. Number of independent solution that we have discussed, right? So Ax equals to 0. A is a n cross m matrix. A is n cross m matrix, and m is greater than n. Let's suppose rank of A is equals to P. I am just taking rank of A is equals to R, right? So what would be number of free variables? M minus R would be my free variables. Would be my free variables. So independent solutions would be m minus r. M minus r. That would be my independent solution. Now for independent vectors, what they are saying that m minus r independent vectors, right? M minus r independent vectors. And can I get one thing, that rank of A is r, but also rank of A is less than equals to minimum of n comma m. And what is minimum of n comma n? That is n. Minimum of n comma n is n. So rank of A is always less than equals to n, because I do not have given the result in m minus n or m minus, I do not have a result in m minus r. So I am just converting it into m minus n. So they are saying that independent solution m minus r. ठीक है, m minus r. So if I will convert it, r is less than equals to n. If I'll multiply it with negative sign, greater than equals to n. If I'll add m minus r greater than equals to m minus n. Right? So when they have said that, now let's see the statement. There exists at least m minus n linearly independent solution to this system, and they have said that there exists m minus n linearly independent vectors such that every solution is a linear combination of these vectors. अच्छा, अब इसको बढ़ते हैं. m minus n linearly independent solution at least मिलेंगे. Obviously ना, rank है तो मुझे ज़्यादा ही मिल रहे हैं, right? If r is a rank, if r rank, if at least m minus n तो मिलेंगे ही मिलेंगे ना, because of this. At least m minus n तो मिलेंगे ही मिलेंगे. Why is that? Because I am saying that I am getting, if rank is R, I am getting m minus R linearly independent solution. If R can be up to n, if R would become n, at least I have m minus n linearly independent solution. If R is less than n, let's say n minus 1, n minus 2, तो मुझे उससे ज़्यादा ही solution मिलेंगे. I'll get more solution to that. But this statement is true that there exists at least m minus n linearly independent to solution to this system. There exists at least m minus n. Now in this saying m minus n linearly independent vectors exist करेंगे such that every solution is a combination of these vectors. But they are saying that m minus n exactly combination work करेंगे. But अगर मेरी rank n minus 1 हो गई, then I'll have m minus n plus 1 vectors. Then solution would be a combination of m minus n plus vectors. So this is not true. So I told you A and C is not true because we do not define anything on the number of variables which are 0 or non-zero, but we define number of independent solution. Option B is correct here, right? So this is also they have asked in GATE DA, right? So we have solved different types of question based on homogeneous and non-homogeneous system of linear equation. So yeah, so these are all the questions. We are going to continue in the next video with the topic LU decomposition. So that's all for this video. Thank you guys.